Hello, ladies and gentlemen, this is Mrs. Gallagher, and today we're going to discuss linear versus nonlinear functions. So let's review some key vocab terms. A function is a relationship that assigns exactly one output value for each input value. So a function basically has all different x values. A relation is a set of ordered pairs. So relation is a set of ordered pairs. It's basically a coordinate. You have your x value and your y value. The domain is the possible values for the input or independent variable of the function, the x value. So domain is the possible input or independent variable of the function. It's the x value. Your range is the possible values for the output or the dependent variable of a function, the y value. So the range is all the possible values for your output. It's a dependent variable, and it's also the y value. Our next term is linear, and a linear function is a function that forms a straight line when graphed. A nonlinear function is not a straight line when graphed. So nonlinear is not a straight line when graphed. Our next vocab term that we need to know is new. It's called a parabola. And a parabola is a U-shaped curve of a quadratic function, and each time you have an x squared. So a parabola is a U-shaped curve. And we'll look at some examples of parabola later on in these notes. So now let's compare some graphs below. Okay, so now let's compare some graphs. We have a linear, a quadratic, and an exponential function. Let's look to the left at a linear function. Notice it's a straight line. That is a linear function. Now, if you look at this function, if we look at the equation, it says y equals mx plus b. And our x value is our input. So whenever we have our x value by itself, and it does not have an exponent, that indicates it's a linear function. So a function is linear in an equation. The variable, the x value, the input, does not have an exponent. If we look at the equation, there's no exponent in this function. Now the next two graphs, quadratic and exponential, are both nonlinear functions. So these are both nonlinear functions. If you look, there is not a straight line in either one. Also, let's look at the equations, look at the functions. And if you notice your input value, a times x squared, there's an exponent. There is an exponent. There's also another exponent in the exponential function, b to the x power. That is an exponent. So when a graph is nonlinear, that means the variable, the input value, the x value, has an exponent. So when a graph is nonlinear, that means in the equation, there is an exponent. It has an exponent. Let's look at the quadratic function. If you notice, we have a U-shaped function, and we just learned this new vocab term. The U-shaped function is called a parabola. So this is an example of a parabola, a U-shaped figure. So now let's look at some differences between linear and nonlinear functions. So let's look at example 1. It says make a table for the following function and graph it. Y equals 2x plus 1. So this is our function. Remember, your x is your domain and your y is your range. We are given our domains here. So now we're going to plug in our domains to find our range. So we have y equals 2 times negative 2, and you're going to add 1. 2 times negative 2 is negative 4, plus 1 is negative 3. So your input is negative 2, and your output is negative 3. So negative 2, negative 3. All right, next we have y equals 2 times negative 1 plus 1. 2 times negative 1 is negative 2, plus 1 is negative 1. So your coordinate is negative 1, negative 1. Our next coordinate is 0. So you have y equals 2 times 0 plus 1. 2 times 0 is 0. 0 plus 1 is 1. So 0, 1 is your coordinate. Next one, x equals 1. So y equals 2 times 1 plus 1. 2 times 1 is 2. 2 plus 1 is 3. So your coordinate is 1, 3. Your next input is 2. So y equals 2 times 2 plus 1. 2 times 2 is 4. And 4 plus 1 is 5. So your coordinate is 2, 5. So now your coordinates, we're going to graph it on the coordinate plane. So we have negative 2, negative 3, negative 1, negative 1, 0, 1, 1, 3, and 2, 5. So you're going to draw your line. Make sure you have arrows because it keeps going. And then your last step is to label y equals 2x plus 1. Now if you look here, it says, is this linear or nonlinear? Well, we have a straight line. Therefore, this is a linear function. How else can you tell it's a linear function? If you look at your function right here, you just have one x value. There's no exponent. Therefore, if you see no exponent, it's going to be a linear function. It'll be a straight line. Let's do another example together. Okay, so let's look at example 2. It says, make a table for the following function and graph it. Y equals x squared plus 2. So our function here is y equals x squared plus 2. And we have our domains. So we're first going to plug in y equals negative 2 squared plus 2. Negative 2 squared is negative 2 times negative 2, which gives us a positive 4. And 4 plus 2 is 6. So our first coordinate is negative 2, 6. Okay, next we have negative 1. So we have y equals negative 1 squared plus 2. Negative 1 times negative 1 is positive 1. 1 plus 2 is 3. So your coordinate is negative 1, 3. Next one, x equals 0. You're going to plug it in. Y equals x squared, 0 squared, plus 2. 0 squared is 0, plus 2 is 2. So our second coordinate is 0, 2. Okay, our next one is 1. So y equals 1 squared plus 2. 1 squared is 1 times 1, which is 1. And 1 plus 2 is 3. So our coordinate is 1, 3. And our last one, our x is 2, so we're going to plug it in. Y equals 2 squared plus 2. 2 squared is 4, because 2 times 2 is 4. And 4 plus 2 is 6. So our coordinate's going to be 2, 6. Okay, so now that we found our coordinates, we are now going to graph them. So our first coordinate is negative 2, 6. Our second coordinate is negative 1, 3. Third coordinate is 0, 2. Fourth coordinate is 1, 3. And our last coordinate is 2, 6. And we're going to connect them. And if you notice here, we made a parabola. So this we just graphed was a parabola. And we're going to name it. We're going to label it y equals x squared plus 2. And now you're going to ask yourself, is this linear or nonlinear? And it's not a straight line, it's a parabola, therefore it's nonlinear. Now if you look at your function, y equals x squared plus 2, if you notice there's an exponent here. So whenever we have an exponent, that also indicates it's nonlinear. So what is the difference between the two graphs that we just graphed? In graph number 1, it's linear. There's no exponent. So graph number 1, in example 1, it's linear. There was no exponent in the function. And graph 2, it's nonlinear. There was an exponent in the function. So graph number 2 was nonlinear, our second example, and there was an exponent. So now what I'd like you to do is the you try section. So please complete number 1. You are finding your coordinates, graphing it, and telling me if it's linear or nonlinear. And you are doing the same thing in number 2, finding your coordinates, graphing it, and tell me if it's linear or nonlinear. And we will discuss this in class. Thank you.